Hey guys, welcome to the next surface area lesson. Today we're going to be looking at a new shape. We're going to be looking at pyramids. But before we go through our examples, let's look at what a pyramid is. So a pyramid is going to be a shape that has one base and triangles on all other faces that come up to a point. So this is a square base pyramid because remember we named shapes by their base. So this is a square pyramid. So since the square has four sides, if I unfold it, there are four triangles. So if I wanted to find the surface area, I would find it up one square and four triangles. But there are different types of pyramids, just like there are different types of prisms. So here I have a triangular pyramid. So it has a triangular base and triangles on all the other sides. So this time, instead of four triangles, there are only three triangular faces and one triangular base, because there's a triangle coming off of each side of the base that folds up to their point. This is a hexagonal pyramid. So we have a hexagon base, 6 sides, which means we have 6 triangles, one coming off of each side. 1, 2, 3, 4, 5, 6. Here it is. Same thing with our pentagonal. Once again, we have a pentagon base and a triangle coming off of each side. So 5 triangles, 1, 2, 3, 4, 5, and 1 pentagon base. So now that we know what a pyramid looks like, we're going to go through the practice examples you see listed in the module. So if you want to go ahead and draw them down, print them out so you have them with you, or if you just want a sheet of notebook paper or a whiteboard with you so you can work along with me. You might want to also have a calculator. You can use a calculator on these. And also you might want your formula sheet, if you haven't memorized them yet, for your shapes that you had last week, just to use as a reference. Okay, so let's get started. Let's look at this first problem here. Here we have a square pyramid. So remember, the surface area is the sum of all the faces, all the areas of all the faces on the figure. So let's start with the base. I like to start with the base. And in this case, this is a square base pyramid because the base is a square. So here's our base in blue. It is a 4 by 4 square. So our square base is a 4 by 4 or 16 meters square. Then we have a triangle coming off of each square. So I'm going to go around and I'm going to trace these triangles. And we're going to see what they look at. Remember, a triangle is base times height divided by 2. So to find, let's look at this first triangle here. It's got a base of 4 and a height of 5. So we have 4 times 5 divided by 2. 4 times 5 is 20, divided by 2 is 10 meters squared. But if we look, all of these are going up to the same height, 4 and a 5. So I have 4 of those. So I have 3 more triangles that have a base of 4 and a height of 5. A base of 4 and a height of 5. And a base of 4 and a height of 5. All which have 10 meter square areas. So now remember, surface area means I add up all of these faces. 10 plus 10 plus 10 plus 10 is 40, plus 16 is 56 meters squared. So that's our first surface area of a pyramid. I think you guys did great. So let's look at another one. This is what we call a net. It is the unfolded shape. Sometimes you'll see this. This is like the shape when I unfolded it a while ago to show you. So let's start once again with the base. It is a square base pyramid. Okay, so it's got a 9 by 9 base, which is 81. And the triangles, remember the triangles on a square are all the same because they all have the same base. Because on a square, all the sides are the same and they're all going to fold up to the same height. That pyramid height is never going to change. It's always this tall. It's never going to change. They always fold up the same amount. And if it's in a square, all the sides are congruent. So are all 4 triangles. So we really only have to solve that one time. So if we look here, it's a 9 base by 12 tall. And remember, it's base times height divided by 2. So if we do 9 times 12, we get 108 divided by 2 is 54. And we have the same for each of these. Centimeters squared. Put our units on there. And then remember that the surface area is just adding all of these up. So we have 54 for the 4 times. So you could type in 54 times 4, or you could go 54 plus 54 plus 54 plus 54 if you don't see that multiplication shortcut. And then don't forget our square base. That's a common mistake. So don't forget that. And you get 297 centimeters squared. Awesome. So now let's look at another example. In this case, it doesn't reveal all the sides to us. So we gotta imagine what's there. This isn't a square pyramid either. This is a rectangular pyramid. So if we look here, I'm gonna dot in right here. We have a 5 by 3 rectangular base in this case. So since it's a rectangle, we're not gonna have all 4 congruent triangles anymore. So let's first worry about this rectangle. 5 times 3, 3, and we get 15 inches squared. So now let's look at this front triangle here. I'm just going to put the front triangle. Okay, so we have a 5 base and a 4 tall. So base times height divided by 2. 5 times 4 is 20 divided by 2 is 10 inches squared. But the cool thing about it is that's also our back, because the back rectangle side is 5 and the pyramid's still 4 tall. So our back triangle is also a 5 by 4 divided by 2, or 10 square inches. But now we need to look at our left and our right, because they're a little bit different in this one. So let's look at that left triangle here and the right triangle. Let's look at both of those. If I trace this right triangle here, it's a 3 by 4 divided by 2. Base times height divided by 4. The left side, remember rectangles are congruent, is also a 3 by 4. Base times height divided by 2. Now 3 times 4 is 12 divided by 2 is 6 inches squared. So now let's add it all up. Remember, surface area means add all the sides together. And we get 47 inches squared for the surface area of this pyramid. So just because we can't see all the sides, we got to remember a rectangle has 4 sides. So there are 4 triangles we have to find, one coming off of each side. So we did 2 square pyramids, a rectangular pyramid. Let's try a triangular pyramid. So sometimes they're actually kind of really nice to you, and they go ahead and give you the area of the base. So I'm going to go ahead and write down what shapes I know we have in a triangular pyramid. So we have the base triangle, and then we have 3 triangles. So we have the left, the right, and the back. The left, the right, and the back. So I have a base triangle with a triangle coming off of each side, 4 shapes that I have to look for. Well, this one, they were really nice to me because they already gave me the area of the base. I don't have to do any work, and I already have 1 shape filled in. So it always is very important to read the problem and see what they give you. So now let's look at the triangle sides. The left is a 10 by 12. Base times height divided by 2. 10 times 12 is 120. Divided by 2 is 60. So let's look at the right. It also has a base of 10 and a height of 12. So it is also going to have an area of 60 meters squared. And the back is also a 10 by 12. Because that base triangle is an equilateral triangle, it works very similar to the square. If all sides are congruent, so are the triangles coming off of them. Now we can just add them together. If you see the shortcut to do 60 times 3, you can. Otherwise, just do 60 plus 60, plus 60 plus 60. Plus, don't forget that base. That's the common mistake to leave it out. 223.3 meters squared. Perfect. So we've now completed our first triangular pyramid, and you guys did awesome. So hopefully you're working along with me and keeping these for you to look at and reference as you move through. So let's do our last one. It is another triangular pyramid, but this time they did not give us that base triangle. So we have to do a little bit of work. So we have the base triangle, plus we have 3 triangle faces. I like to write out what shapes I'm finding. Okay. And the way this one is written, I almost feel like we have a front and a left and a right. However you want to call them, a back. As long as I will trace through them so we can see which ones are which. But remember, the base is always that bottom one that the pyramid's sitting on there. So let's do that one first. So the first thing we need to notice is this is an equilateral triangle. It tells me all sides are equal. So this back side is also 6. So the base of this triangle is 6 and the height is 4. And I know that this is the base and that's the height, because it has a right angle right there. Remember, the height always comes down onto the base. So we have a base of 6 times the height of 4. And don't forget, the area of a triangle is base times height divided by 2. Okay? So 6 times 4 is 24. And you can use a calculator if you need to, but hopefully you know that one. And 24 divided by 2 is 12. So we got 12 centimeters squared for the base triangle. Now let's go ahead and look at this one that's sitting closest to the front. And it has a base of 6, because remember this is an equilateral triangle, times a height right there of 10. But it's base times height divided by 2. 6 times 10 is 60 divided by 2. Once again, if you need the calculator, you can. Hopefully you know that. But it is divided by 2, which is going to be 30. That's why I put that 3 there. All right, so let's keep looking. We got 2 more triangles to find. It's equilateral, so this is also a 6 by 10, which gives us another 30 centimeters. And this back one back here is equilateral, so this side's also 6 by 10. So all we have to do is add up the area of all our faces. We got 30 plus 30 plus 30. Plus our 12, don't forget that base. And we've got 102 centimeters squared. Perfect. Think you guys are gonna do great. You are now ready to go try these out on your own on the module. So work your way through the assignments. I know you are ready. You guys are gonna do great. And don't forget, we have office hours on Monday, so you can come and get help if needed. I wish you the best of luck. Have fun working on some of the surface area problems.